is Serrano-Correa. This is Chapter 4, using Control Structures, Part 1. There we go. So in this first video, we're going to go over these 3 bullet points. I then have a different video that's going to go over part of this last bullet point. It's going to go over these right here, the if and the if else, these control structures. Then I'll have a separate video just for the switch statement. So we're going to look at control structures. We're going to look at the relational and the logical operators that are used in Java. And we're going to look at how to form and evaluate logical Boolean expressions, meaning expressions that return true or false. There's 3 types of methods of processing a program. The first type is called sequence, and sequence looks like this. So we have statement 1, it's what you've done for lab 1 and for lab 2. You process the first statement, then the second statement, and we do each statement in sequence from the top to the bottom. The second type of way of method, something that actually every program is done in sequence, but we can add something called branching. So within your sequence, you can have statement 1 and statement 2, and then you can add something called a selection statement like this, where it branches out depending on some kind of expression that you have here. So you have some kind of logical expression that gives you a true or false, and then the program is going to then decide if to execute the true statement or the false statement side. And then we have looping, and this is a repetition, something that you want to repeat in your program. So you can have a sequence, then after the sequence you can have some kind of condition that asks, if what they enter is true or false. Could be an example. And then you could have also a repetitive statement, and typically you'll see repetitions used when you're checking for data. So maybe you don't want to keep you want to keep the user entering some kind of data until that data is entered correctly. So you can check, for example, if you're asking for a number between 1 and 100, then you'll just keep asking for that number until they enter something between 1 and 100. If they enter something less than or greater than, you would just loop around and ask again. So that's the repetition. And all large programs are going to have a repetition and a selection statement in the program, or statements. And everything in a program is executed in sequence. So I can take the selection, put it here after statement 2, and it will execute. And then after it's done, then it will go to the next statement, statement 3. So the thing that allows us to be able to get back a true or false is, or one of the things is called a relational operator. So we have Boolean operators and relational operators, and those both will give you a true or false answer. When we work with relational operators, we have a condition, and that condition is represented by a logical expression in Java. And the logical expression has a value of either a true or a false. So these are our relational operators. This this means that you're going to compare two things and you're going to see if they're equal to each other. And just like in C++ and in other languages, we use two equal signs because one equal sign means to assign. So if you use one equal sign, you're assigning a value like x equals 10, but two equal signs means that you're comparing the value on the left to the value on the right. Not equal to, less than, or equal to, greater than, or equal to. So here we're just saying that we can use relational operators with primitive data types. Like remember when we were talking about ints and floating point numbers and chars. Also, you can use their Unicode collating sequence to compare them. And what that is saying is that each character has a unique Unicode value. And we're not going to be doing this way. We're not going to be comparing it to the Unicode value. We're going to compare it to the actual character. So we can compare like is A equal to A, or is the number 5 equal to a number 5, or is the character 5 equal to the character 5, that kind of thing. So here's how we're going to be using the relational operators. So here it's comparing a space, which is the value of 32, and it's saying, is that less than A? And A has a value of 97, and so that would be true. So a space is less than A. Now here we're saying, is capital R greater than capital T? Well, if you just think of the alphabet, and you think about where does the R in the alphabet come? So R comes before T, so this would be a false statement. But also if you look at this chart, R has a value of 106, T has a value of 108, so R is less than T, not greater than. Here says it's plus less than the multiplication sign. Again, we have to look here and see where's the plus sign and what's its value. Multiplication, its value. So multiplication is less than addition. So this is false. And here we're saying, is this less than or equal to this? Now, this is just showing you how the Unicode values are used. When you're programming, you're going to be comparing things like, did they enter the word no? Did they enter the letter N? Or did they enter a number between 0 and 100? Or is the number negative? Like, is the number less than 0? Or is the number greater than 0? Maybe you're trying to find a number, having them enter positive numbers. So this is not something we would do except maybe comparing two letters. But it's just showing you how it uses this chart to know what comes before what. These are the logical Boolean operators, which will also be discussed in the next little video that I want you to watch. And so I'm just going to talk about it briefly here. This is not. So if you put this in front of anything that's true, it will make it false. If you put it in front of anything that's false, it would make it true. 2 ampersands means and, like, is the number between 1 and 100? Is the number less than 0? Let's see, is is the student's name John or Mark? Like, let's say we're looking for John or Mark. So you say, is the name John or Mark? So it can be either John or it can be Mark. We're looking for either one of those names. So again, with the logical, the relational operators, we're going to get a true or false. And also with the logical Boolean operators, we're also going to get a true or false. So here's an example. We're saying, first of all, we do what's in parentheses. So in parentheses, we say, is A greater than B? So again, you want to look at this chart here. Capital A is 65, capital B is 66. So A is not greater than B. So this would be a false statement inside the parentheses. Not false would give you a true statement. Is 6 less than or equal to 7? That would be true. Not true would be false. Okay, here we're using the Boolean and. And so what the computer is going to do, it's going to check to see if this is true or false. Then it's going to check to see if this is true or false. Now, if this one is false, the compiler doesn't even check this one, because if one of these is false, both will be, the whole thing is going to be false. Okay, so is 14 greater than or equal to 5? Yes, that's true. So then let's check this side. Is A less than B? That's true. So then this expression will give you a true value. When you have an and, both of the both conditions on each side have to be true for the whole expression to be true. Is 24 greater than 35? That's false. So then we know that this whole expression is going to be false, because you just need one false. Okay? Even though this is true with an and, it has to be this and that. Okay, the or operator. When you have an or operator, you just need one of the two sides of the condition to be true. So either the left side needs to be true or the right side needs to be true. So if you have two truths, you get a true. The only time you're going to get a false with an or is if both are false. Both sides are false. The precedence of operators. So we have an order of operation for operators, just like we do for like plus, minus, division, that kind of thing that you've studied before. So the very first or the highest precedence, it's going to be not. And then the plus and the minus are not addition and subtraction, but it's like saying -5. Okay, you're making something negative. Like you have a number in parentheses and then you have a negative on the outside, and you make everything negative. Second, it's multiplication, division, and modulus. The percent remembers modulus. It gives you the remainder of two numbers. Now, these are on the same row. That means that they all have the same precedence. And so whatever you encounter in your equation from left to right, whichever one of these comes first, it's the one that you're going to execute, because they all have the same priority. And then we have plus and minus, again, same priority, whichever one comes first, reading left to right on your equation. Then you have all the less than, equal to, greater than, equal to, greater than. Then you have equal to, not equal to, and, or, and the assignment operator is the very last thing that gets executed. So here's an example. Let's say that we have this huge expression right here. Super, super long. Well, first of all, we have to do what's in parentheses. And actually, parentheses are not even on here. So parentheses and square brackets are first. And also, the other thing I don't see on here is exponents. So you have parentheses and, let's see up here, you have parentheses and square brackets is executed first. Then exponents are executed next. Then this, goes like that. Okay, so we're going to do this first. And within this, we have a less than sign and we have a multiplication sign. So what happens first? Should we say 17 less than 4, or should we multiply 4 times 3? Well, looking back, multiplication, all these three have to happen before you compare. Addition has to happen before we compare. So we would say 4, and multiplication comes before addition. So we have to say 4 times 3 is 12. 12 plus 5 is 17. Is 17 less than 17? So this is a false statement here. This is false. And then we go to the next one. So here we have, this is comparing to see this is going to be equal to that. We're going to multiply first. 8 times 2 is 16. 4 times 4 is 16. Is 16 equal to 16? Yes, that's true. So now we have false or true. And by the way, the or statement is after the and statement. So these two are going to be compared first before we compare these two. So we have false, true, and then this one. 3 plus 3 is 6. Is 6 equal to 6? That's true. Not true is false. So now you have false and true is false. False or false is false. And I don't know that I can write on here. Sure there's a way, but we'll just keep going. Okay, so in this example, we have a Boolean operator called found. It's initialized to true. A double, hours, initialized to 45.30. Double, overtime, initialized to 15 hours, or maybe $15. Notice we're starting our variables with lowercase. This is a reserved word, so it has to be written exactly as you see it here, lowercase double. Overtime has 2 words, so we start with lowercase, and then the next word we capitalize. And again, remember that these are variable names, so it's not that we have to start with lowercase and have a capital for the second letter, but it's something that you'll see throughout the Java language and the C++ language. So it's something that we follow, and we always define our variables like this. Count is 20, and character is B. So this is a character type. Characters have to be in single quotes, no spaces inside the single quote, and only one character in there. Otherwise, it's a string if you have more than one character. So So if we say not found, found is equal to true. So not true will give us a false. Is ours greater than 40? Well, ours is 45.3, so this would be a true statement. This gives us back a true. Not found would be false, because this is true, not true is false. So because we have an and, automatically we know that's going to be a false statement. Again, found is true. Ours is definitely greater than or equal to 0, because ours is 45 point something. So we have true and true is a true statement. Not true is false. Here we add first. Addition comes before the logical operators, less than or equal to. So hours plus overtime, $15 plus 45 is 60, right? So 60.30. Okay, these must be hours. So 15, yeah, anyway, whatever it is, 5 plus 5, so we have 50, 60.30. So is 60.30 less than or equal to 75? That would be true. Is count greater than or equal to 0? Well, count is 20, so that's a true statement. 20 is greater than or equal to 0. And 20 is 20 less than or equal to 100? That's true. So this is a true statement. Is capital A less than or equal to B? Capital A is less than B. And is capital A less than or equal to Z? Yes. So this is a true statement. A note here, it says be careful when forming logical expressions. Some beginners make the following common mistake. Suppose that num is an integer. Here's num. Further, suppose that you want to write a logical expression that evaluates to true if the value of num is between 0 and 100. So when we want to check the bounds of a number, we always check to see if it's between one number and the other number. And that's when we use the and operator. Always when you have to see if it's between 0 and 10. In this case, we want to include 0 and 10. So we're looking to see if the number is a 0 or a 1 or a 2, 3, 4, 5, 6, 7, 8, 9, 10. And if it's not, then we're just going to get a false statement. The following expression appears to represent a comparison of 0, num, and 10 that will yield to desired results. So a lot of people will write this num, and they'll put num in the middle, and then they'll do the bounds 0 and 10. This statement is not legal in Java, and you will get a syntax error. So this gives you a syntax error because you have to have one number or variable here compared to something here, and then you have to, if you want to do it compared to 10, you have to then repeat the variable that you're comparing to 10 again. Therefore, the preceding expression is equivalent to this. So you're saying is 0 less than or equal to num? So that would be, let's say it's true. Then you would say is true less than or equal to 10. And because you cannot compare the Boolean values true and false, right here, we can't compare true and false to 10, it gives us a syntax error. So the correct way would be to say is 0 less than or equal to the number, and is the number less than or equal to 10. That works. Also, I would rather say is the number greater than or equal to 0, and is the number less than or equal to 10. That's how I would write it. Okay, so we're going to stop here. And in the next video that I included, it's a video that somebody else made that I found online. It's a really good video. It's 20 minutes long, but only watch the first 10 minutes. You're more than welcome to watch the rest, but really all you need is the first 10 minutes. I really like the video because he types up an example, which is great, and then he goes into showing you how to be able to check and step into the code so that you can see as the code is executing. And you'll need this to debug your program. So make sure that you watch the next video provided. It will also go into if statements and the nested if statements. Then I'll do another little video about the switch structures.